Welcome. The title of today's notes worksheet is Exponential Properties. This lesson represents the beginning of a unit dealing with a variety of algebraic skills, what works numerically, what doesn't work numerically, and so we'll be taking a look at that today in the context of dealing with exponents. And a variety of properties to kind of go over, and also a variety of examples to look at. So let's start it out immediately here. At the very top of your page, it should say something like, specific example of multiplying powers with the same base. And I tried to be as concrete as possible with this so you can kind of see these properties develop. So the first one I see is 2 to the 4th times 2 to the 3rd, so 2 powers, same base. And if you kind of look at this, I expanded it out for you. 2 to the 4th, of course, we all know means 2 times 2 times 2 times 2. There's 2 to the 4th. Here's the times right in the middle, and there it is in the expanded version. And then 2 to the 3rd, of course, is 2 times 2 times 2. And as you can see, basically I have 7 factors of 2 multiplied together, all multiplication, all the same base, and so we can write that as a power as 2 to the 7th. And so you can kind of see that 2 to the 4th times 2 to the 3rd produces 2 to the 7th, and then the question would become, what can I do with these exponents to kind of shortcut this? Well, as you all know, of course, when we multiply powers with the same base, I add the exponents. 4 plus 3 gives me my 7 right there. And so the very first property that we're going to take a look at is what's called the product rule. If everyone can box that up for me, that would be great. And as you can see, in a very abstract way, it says exactly what I just developed above. When I multiply 2 powers with the same base, I keep the base. Let's be clear about that. Keep the base and add the exponents. And you can see why we kept the base right here, of course. They're all factors of 2. So what I'd ask you to do is just pause the video for a moment, and you'll be doing that a lot during this lesson. Just pause the video and see if you can knock out example 1, A, B, and C for me, and then come on back and see if you got it right. Okay, well, let's see how you did. We'll just keep everything nice in the base that it's in here. So I have 3 to the 5th times 3 to the 4th. So keep the base and add the exponents. Multiplying 2 powers with the same base, that's the first property, what's called the product rule. 4 to the negative 2nd times 4 to the 5th. Again, keep the base and add those exponents, and I end up getting 4 to the 3rd. Now this one's an interesting one right here. I like letter C. I have 2 to the 5th times 4 to the 1st, and at first glance, it does look like I cannot pull this off here, because if you sort of think about that, this is not something like 8 to the 6th. That would not be right. I cannot really multiply powers that don't have the same base. Numerically, the left side is not equal to the right side. So unfortunately, that doesn't work. We would either leave it or see if we can find a way around it. And not sure if he found the way around it, but I was kind of looking at that 4 to the 1st and understanding powers there. 4 to the 1st can be written in the same base as 2 to the 5th, base 2. And so 4 to the 1st is really 2 squared. And now once you see this, it's 2 to the 5th times 2 to the 2nd, so that's actually 2 to the 7th. And so that would be one way to kind of pull this off. Now you don't have to write this on your paper, but numerically 2 to the 7th is 128. And if I look up here at the original, just kind of looking at this piece, just to see if everything worked out, 2 to the 5th happens to be 32, 4 to the 1st is 4, and 32 times 4, everybody, is 128. So this is the same as this, and so this is going to be our answer right here. Okay, so nice, just product rule, multiplying 2 powers with the same base, you keep the base and add the exponent. Let's go on to the next. So just a nice concrete example, dividing powers with the same base. And so you see 2 to the 5th divided by 2 to the 3rd. And of course, everybody, I expanded out 2 to the 5th for you in the numerator. And I expanded out 2 to the 3rd in the denominator. And this is a skill that's going to come up a lot for us over the course of this unit, when to cancel things out in the numerator and denominator. And as a matter of fact, these are what are called common factors. So a common factor of 2 on top and bottom can cancel. Another common factor of 2 on top and bottom can cancel, and another one can cancel. And so as I slash and burn those factors of 2, you kind of see what's left over, and I end up having 2 factors of 2, 2 times 2, which of course is 2 squared. And again, you can potentially see the shortcut there. Makes pretty good intuitive sense. When I multiplied powers, I added the exponents. Well, when I divide powers with the same base, you can see you keep the base and you subtract the exponents. 5 minus 3 is 2. So everyone, when you do get an opportunity here, let's go ahead and box up number 2. And it says exactly that. Dividing two powers with the same base, keep the base, subtract the exponents. Okay, well, I'd ask you to pause the video again and try example 2 if you get a chance. And then I'll take a look and see how you did. All right, let's go for letter A. 5 to the 6th over 5 to the 1st. I just kind of put a little 1 right there. It kind of helps me when I'm dealing with exponents. And now I do see, of course, two powers with the same base. And if I really kind of treat that property properly there, I should just get 5 to the 5th. Okay, good. In this case right here, have to do that, have to do that. So divide the powers base 2, divide the powers base 3. When I divide the powers base 2, I keep the 2. And 3 minus negative 2 happens to be 5, so it's 2 to the 5th. And then I'm going to go ahead and divide the powers base 3. So I'm going to do a little multiplication symbol right in between there. And I'm going to combine these with my division, my quotient rule. And it looks like I'll go ahead and keep the base and subtract those exponents. Negative 2 minus negative 3, it should be positive 1. So 3 to the 1st, or just 3 if you want, of course. All right, so what we have at this stage is 2 out of the 7 properties, product rule and quotient rule. I'm going to go to my next screen here. Okay, and this one definitely comes up a lot. We'll be removing plenty of parentheses with these algebraic expressions. So this one would be 2 to the 3rd, then also to the 4th. Power to a power, essentially. And so what I did is expanded it out. When I saw that 2 to the 3rd raised to the 4th, what that means is 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. So 4 factors of 2 to the 3rd. And then if I look at this, this is very reminiscent of what we saw above, where I'm multiplying powers with the same base, and I would just add all those exponents. 3 plus 3 plus 3 plus 3 should give me 12. So there's the product rule in action. And as you can see, kind of shortcutting this, you see that if I just sort of looked at the beginning expression and my overall answer there when it was simplified, to remove those parentheses, I kept the base and I multiplied those exponents. 3 times 4 is 12. So power to a power, known as the power rule here, number 3. Everybody box that one up for me. You see when I go ahead and have a base raised to a power, and that's raised to a power, in order to get rid of those parentheses and clean it up, I multiply those exponents. Okay? Good. Now let's see if you can combine a couple things together. So please, again, pause the video and do example 3 for me. All right, well, let's see how you did here. I'll take mine in 2 steps. My first step is usually to remove parentheses. So I would go ahead and do my power rule right here, and 3 times 3 is 9. So I get 2 to the 9th right there. And then same thing down here, remove the parentheses. 2 times 2 is 4, so I get that. And what you want to have it do is kind of jump off the page at you and recognize more simplification here. This is dividing powers with the same base, so I would keep the base and subtract those exponents. So 2 to the 5th would be your overall answer. Nice. Here just sort of a variable as our base, so x to the 4th raised to the 5th. Looks like our power rule on that, so 4 times 5 is 20. Multiplication symbol in between, and then x squared raised to the 4th, so 2 times 4 is definitely 8. And then just continually recognizing what you can do to simplify these powers. In this case, it looks like it's the product rule, and so I'm going to keep the base and add those exponents. And x to the 28th would do. All right. So very nice. So far we have 3 out of, I believe, the 7 properties taken care of at this stage. They're going to get harder. So just kind of let's build it up one step at a time. All right, wonderful. Let's go on to the next. So this is what's called product to a power. Now I know, of course, I know my my order of operations. Theoretically, I would do the parentheses here first. I know 2 times 3 is 6, and I can just take 6 to the third and kind of get that. But I did want to be kind of concrete so you can see the property emerging from it. So kind of bear with it in this case. So when I see 2 times 3 raised to the third, what does it mean to be raised to the third? Well, it means 3 factors of 2 times 3. And so that's what 2 times 3 to the third would really mean. And as we all know, this is just all multiplication straight across. And with multiplication, it is what is called commutative, meaning the order doesn't matter. So what I'm going to do, and what I'm currently doing right up there, is changing the order of the way it was written. So this is the same, of course, as this right there. 2 times 2 times 2 times 3 times 3 times 3. And then as you can see, if I can consolidate this a little bit, 2 times 2 times 2 is 2 to the third. 3 times 3 times 3 is 3 to the third. And so I have now my 2 powers in those 2 bases right here. And if you notice, when I removed the parentheses in my final answer, it was by taking this to the third power and this to the third power. And that's exactly what we're going to do. When we have a product raised to a power, this goes to that power and that goes to that power. So I believe we're going to box up the next 2 properties pretty much in a row here. What we just developed, everybody, would be number 4. And so let's go over that. That would be products raised to a power. And as you can see, when I have a product inside parentheses raised to a power, in order to remove the parentheses, everybody, you go ahead and raise each one of those to that power. And again, you kind of saw why that worked with my previous example. Good. The same thing works, by the way, with quotient raised to a power. So this one doesn't get a specific example going with it, but it's basically the same. And so in this case, when I have a quotient raised to a power to remove the parentheses, I take this to that power and that to the power. And notice they're in the same spots, and that's looking great. So there is what is called product raised to a power and quotient raised to a power. This is a great one right here, everybody. This is a little investigation we're going to do just pretty quickly. The question I have for you is there a sum property or a difference property with exponents? So we just saw there's a product property. There's a quotient property. That's 4 and 5. Is there a sum and difference property as well? So let's check it out here. Let's see, again, is it numerically legitimate? And can we form a general algebraic property from it? Or is it not algebraically legitimate, and we would have to be careful of doing something like that? Well, let's find out. So you can grab a calculator if you'd like and sort of look at this. I think I can do most of this mentally here. But basically, I have the 3 plus 2 raised to the third. And is that the same as taking 3 to the third plus 2 to the third? Well, if I look at the left-hand side, 3 plus 2 is 5. 5 to the third happens to be 125. So the left side of this equation is 125. And the right side, I end up getting a 27. 3 to the third is 27. And 2 to the third is 8. 27 and 8, that is by no means the same as this over here. So can I just remove the parentheses if there's a plus in between, like I did with those 2 properties above? Absolutely not. Same thing over here. Let's go ahead and take a peek. So 3 minus 2 is 1. 1 to the third is still 1. So the left side of this equation is 1. And the right side of the equation is really 27 minus 8. Obviously, guys, that's not 1. And so is there a difference property? No, absolutely not. So how about we put a slash mark through those equals? The left side definitely is not equal to the right side. You'd be surprised how often in the past, over the years, I've seen students do exactly this. They can see it when it's not concrete. But I've seen students do exactly this. They have said that the left side would be equal to the right side. And that is not the case. It's far more complex than that. To expand this out, it's not quite as easy as just doing those 2. And same with this. So you can write this or not write this. This is totally your call. But that's exactly what I wanted you to at least see, that those 2 are not the same. I'm afraid not. Okay, so there's only a product and quotient property that goes with it. Well, everyone, it looks like I do have example 4, A and B, kind of dealing with products and quotients. So if you don't mind, pause the video there, remove the parentheses on that, and simplify anything that you have going. We could probably start dealing with just numerical values. So instead of something like 4 to the second, maybe you can say 16 or something like that. All right, let's see how you did. So I sometimes think of it as just a little quotient, I'm sorry, a little product right in there, 3 times x squared. So this is the number 4 where I take 3 to the third, and then x squared to the third. Here's power to a power. Have to recognize as they're all starting to come together. A lot of overlap now. Power to a power means I multiply those exponents. 2 times 3 is 6. And then I would probably just go one more step here. I would see 27 and then x to the 6th. Beautiful. This one right here, again, it's all product and quotient. So this is all fine right here. In order to remove the parentheses, I take everything to the second power. So 4 to the second, x to the second, 5 to the second, and y to the second. Keep them in their spots. And then again, what I would just do here, I'd probably do just the 16x squared, and then over 25 and y squared. And that looks good. All right, 5 properties down. I believe just 2 more to take care of. So let's do the second investigation. And so this is going to be coming up with our 0 exponents and our negative exponents. I kept everything just in a nice power of 2. I could do this pattern in any base. I think 2 just works out very nicely, that's all. But if you want to repeat this process on your own, pick a different base, it works out just fine. So here's what I'm thinking. Let's just be very specific about these numbers. 2 to the third, everybody, is 8. Let's go ahead and throw that in. 2 to the second is definitely 4. Put that in, please. 2 to the first, of course, is 2. And so you can see every time I drop an exponent, what's going on to my numerical values, I'm basically losing a factor of 2, or I'm dividing by 2. I hope everyone's okay with that. 8 divided by 2. 4 divided by 2. So in order to get this to work and to fit the pattern, I need to go ahead and continue what I've been doing here. Every time I lose an exponent, I lose a factor of 2. So I divide by 2. And so 2 divided by 2 is 1. And so you can, as I said, do this with any base. And that's what would fit the pattern. So anything raised to the 0 power is 1. Okay, now there is one exception for the base. So really it works for any base except for 1. So that base can't be 0. That's the only thing. 0 to the 0, if you try it on your calculator, is undefined because it doesn't fit any good concrete mathematical pattern like this. But if you tried this in any other base, no matter what, you're always going to get it when it raised to the 0. It's going to be equivalent to 1. Well, let's continue. Just working on down. Again, every time I lose an exponent, I would divide by 2. I lose a factor of 2. So 1 divided by 2 is 1/2. 1 over 2. 1/2 divided by 2 is 1/4. So 1 over 4. And this would be 2 to the negative third. Same thing. Losing an exponent means I divide by 2. So that would be 1 over 8. And I'm hoping you've kind of seen this piece before, the negative exponents. But basically, look at the symmetry here. Look at 2 to the third, and look at 2 to the negative third. As you can see, 2 to the negative third is really the same as 1 over 2 to the third. So negative exponent, the answer still turns out to be a positive value. That actually is key for us, understanding that conceptually. But you can see sort of the situation at hand here, that it really is just 1 over 2 to the third. This, everybody, is 1 over 2 squared. This is 1 over 2 to the first. Okay, so how we treat a negative exponent is the last property here. And so numerically speaking, anything raised to the negative exponent is really 1 over raised to the positive. Okay, I'd ask you to do example 5, just the A and B, and then we'll kind of pause for a minute and see what's going on. All right, well, let's see how you did. I'm looking at quotient rule on this, dividing 2 powers with the same base. And remember, immediately I keep the base. So this is x, and then negative 4 minus 5 happens to be negative 9. So that's the first order of business. Now, if you've kind of seen this before, basically what you want to do is write these with positive exponents and positive exponents only, no negatives. And the reason is it provides more meaning. When I see 2 to the negative third, sorry for coming back to this up here, but when I see 2 to the negative third, it doesn't have a whole lot of meaning for me. It's tough for me to see what that number really is, what it represents. But when I write it with a positive exponent, then I know exactly what that number is. So if I know that 2 to the negative third is really 1 over 2 to the third, oh, then that means it's just 1 over 8. And so writing it with a positive exponent, just in my opinion, provides it with more context or more meaning. So anyway, when I look at this, then x to the negative ninth is really 1 over x to the positive ninth. And this, everyone, will be the answer that I'm looking for. Okay, let's see how you did on B. So it looks like I've got product raised to a power here. So all this stuff to remove the parentheses has to be taken to the negative second. Let's see, so 0 times negative 2 is 0. Negative 3 times negative 2 is 6. 4 times negative 2 is negative 8. And so that looks good. A couple things definitely pop out at me. Anything to the 0 power, we'll assume the base is not 0, by the way. Anything to the 0 power is 1, so that would just be a 1 right there. And then y to the 6th is exactly what we need it to be. Perfectly fine. It's the z to the negative 8th that we're going to change here. And in order to make it a positive exponent, if you remember, it just comes down to the denominator. You obviously don't need the 1. So, I mean, theoretically, this would be a great answer right here. Y to the 6th over z to the 8th. Looks good. Okay. So, 7 properties in the books at this stage. And now they get hard. So what I would ask you to do is take maybe about 6, 7, or 8 minutes, give or take, well, whatever it takes, to be honest. Pause the video and see if you can knock out all 7. Or the alternative, I guess, would be to do letter A, then come back and see how I did it, then do letter B, see how I did it, etc., etc. So you can do it all at once and then watch me do it and see if you got them all right, or one at a time and see if you got them right. But I would definitely pause and see if you can pull this off on your own before just watching me do it. So I'm going to go ahead and give it a try. Here we go. So first order of business is just kind of dealing with this piece, it looks like to me. So 3 is fine. X to the 0 is just 1. So 3 times 1 is still 3, so that's not a big deal. Y squared is still perfectly fine. It's just the z to the negative first comes on down, and I'm liking that piece right there. So I'm getting a 3y squared over z. I'm going to try to box some stuff up here just so you know what my final answers would be. So that's letter A, 3y squared over z. Not a bad way to start. All right, now letter B. I put a little 1 right in there. That helps me. So when I see just a variable by itself and I'm dealing with exponential properties, I'll put a little 1 in for the exponent. So now what I'm going to do is divide the 2 powers, base x, and I'm going to divide the 2 powers, base y. So when I divide powers, I keep the base, and I subtract the exponents. Negative 2 minus 1 is negative 3, so I have x to the negative third. Now this one, again, divide the powers, base y. I can do this right here. Hopefully everyone is seeing exactly that. Dividing powers with the same base. Keep the base, subtract the exponents. Negative 3 minus negative 6 happens to be positive 3. And so I get y to the third. Okay, good. So now I've combined my powers at least. And now I want to just deal with the negative exponents. So the y to the third is fine. In order to make that one positive, it comes to the denominator, and I believe that's what we're looking for. Y to the third over x to the third. Okay. 2 down here. Let's see if we can get the remaining ones. I'm going to remove the parentheses here. It's all product and quotient. So raised to this power, so I take each one to that power. Now there are probably a couple ways to kind of do this. So if you come up with a different approach for any of these, by the way, perfectly fine, as long as we all get the same values at the end, I think it's good. So I like removing the parentheses there first. I think it's a decent step. Don't love all those negative exponents, but I'll deal with that. And you know what I see here is each one was raised to the negative third, and each of these four terms, 1, 2, 3, and 4, has a negative exponent with it. Well, I do need to remedy that. I do need to fix that, and so what I'm going to do is anything with a negative exponent, I'm going to change to a positive. So let's see. If it's in the numerator, it goes to the denominator and becomes positive. And if it's in the denominator with a negative exponent, it goes to the numerator and becomes positive. There we go. And I would probably just work with the numbers a little bit. If you left it like that, it's not a big deal. But I would probably write this as 27y to the third over 8x to the third. Okay, so A, B, and C taken care of at this stage. Let's go get letter D. I'm going to go ahead and put a little 1 there with that y. Just kind of helps me. That is y to the first. And now I'm going to divide powers base x. I'm going to divide powers base y. And I'm going to divide powers base z. Same thing, divide powers, keep the base, and subtract the exponents. Negative 1 minus 2 is going to be negative 3. So that should be x to the negative third at this stage. Again, I like doing that property first. I've seen some students over the years, they like to just deal with the negatives ahead of time. So if you brought this down and then kind of dealt with it, again, there are multiple paths to getting the answers here. You just go with what works for you. But this is just what I see. So in this case, same deal. Divide powers base y and keep the base and subtract the exponents. Negative 2 minus 1, negative 3. And then here's another good one right here. I have z to the third over z to the third. Well, 3 minus 3 is 0. And of course, anything raised to the 0 is 1. So, and you can kind of see that up here. Why is this another way why anything raised to the 0 is 1? Well, if you look at it the way we've developed it, anything divided by itself is 1. So z to the third over z to the third is 1. And so anyway, this cancels out. I have a couple with negative exponents there, so we're going to bring those to the denominator. So x to the third down there, y to the third down there. Again, this is just 1, and as a result, I do just end up having a factor of 1 on top. So, long story short on that one, 1 over x to the third, y to the third. All right, they're going to start to get a little harder down here. Let's see if we can manage it. So I've got letter E. And let's see, I'm going to put a little 1 right in there, maybe put a little 1 right in there. I like removing parentheses first and then dealing with it. So I see that numerator, everybody, and I'm going to remove the parentheses. So it looks like product raised to a power. Let's take each one of those to that power. So it looks like I would get x to the negative second, 1 times negative 2, by the way, and y to the positive second, again, negative 1 times negative 2, everyone. Then down on the bottom, x to the first, y to the third. So again, I like just removing the parentheses there. It's just better visually for me. And then let's go ahead and divide powers with the same base. There we go. And keep the base. And so it looks like negative 2 minus 1 should be negative 3. And then here it looks like 2 minus 3, keep the base, 2 minus 3 is negative 1. Okay, very nice. And at this stage, let's see what I have going on. Both negative exponents there, and so I'll want to go ahead and move those to the denominator. I'm going to try to find a spot for this. I think I'm going to come right over here. And it looks like I'll have a factor of 1 on top. Those two go to the denominator, and this looks like a pretty nice answer right there. So 1 over x to the third, y to the first. All right. Good. Last two, as you can see, they're getting harder. Let's remove the parentheses on letter F, and let's see what happens. All right, so remove the parentheses there, remove the parentheses there. Power to a power. So I have x to the negative sixth, y to the third. Down on the bottom, looks like I have x to the negative sixth and y to the negative second. Again, if you want to put a little 1 right in there, 1 times negative 2 gives me that negative 2 right there. So again, I removed the parentheses just using my properties from above and kind of pulled that off. And then let's go for it. This, maybe you can kind of see what happens right away, but I would divide powers base x, and then I would divide powers base y. So keep the base, subtract the exponents. Negative 6 minus negative 6, you get that 0 again. Now we know what happens there. And 3 minus negative 2, so keep the base. 3 minus negative 2 is 5. Excellent. X to the 0, of course, is just 1. Probably saw that coming before I even wrote it there. And so it looks like you end up just getting y to the 5th. Okay, not too bad. And here's the last one. Wow, it's a killer. All right, well, let's see how you did on this. I'm going to be all over the board, I think, on this one, but let's see how you did. My first step would be to remove parentheses. So I'm going to try to find some room. I'm going to actually try to go left to right. So I'm going to write my stuff over here and then work this way if possible. So see if you can follow my lead. Remove the parentheses on top. I hope everybody kind of did that. So I would get 2 to the 3rd, and then x to the negative 6th, y to the negative 9th, and then still times x to the 6th, y to the 9th. And then let's see, down on the bottom, again, if you want to put a little 1 right in here so you don't forget about it, that's fine. But I get 2 to the negative 1st, x to the negative 1st, let's see, y to the 1st, and z to the negative 2nd. I hope everybody is in agreement on that piece. That's looking good to me. I removed the parentheses just on everything. And now what I want to do is sort of combine all the powers in the same base. And so that's either going to be with the product property or the quotient property. So let's go ahead and see what we've got going on here. I would go ahead and combine these powers base 2. Notice, even though they're numbers, you can still do it. It's dividing powers with the same base. Then, and this is up to you, you can multiply powers with the same base and also divide powers with the same base. So I'm going to try to consolidate. If you have a question on this one, if you don't see my consolidation piece, let me know. But I'm going to start looking at each and every base and see what I can combine. So 2 to the 3rd divided by 2 to the negative 1st. Keep the base and subtract the exponents. 3 minus negative 1 is 4. Now, here's where I'm going to really pull this off. So I'm going to multiply powers, base x, and then also divide. So the way I do that is I'm going to keep this base. Negative 6 plus 6 is going to be 0. And 0 minus negative 1, I'm getting that to the 1st. I'll repeat that one piece. So negative 6 plus 6 is 0, and 0 minus negative 1 is positive 1. And so when I keep the base and I do those two rules, product rule and quotient rule, I get x to the 1st. Same thing on this one. Let's see the y's. So I'm going to keep the base and then add the exponents and subtract the exponent. Negative 9 plus 9 is 0, and then 0 minus 1 is negative 1. Okay, and then last piece, I don't see anything really with that z to the negative 2nd down there, so I just see this as z to the negative 2nd, right? No other z's to kind of combine at this stage. And then I guess it's just simplification from there. So 2 to the 4th happens to be 16. X to the 1st. The y would come down, so this becomes y to the 1st down there, and the z to the negative 2nd goes up. So negative exponent on the denominator of a fraction, bring it up, and it becomes positive. So G is as hard as it gets. If you can see that one and pull that off step by step, you've got it. If not, please ask and be happy to kind of take a look at that with you. If you looked at it in a slightly different way and maybe a couple things got lost there, you'll let me know, and I can see if I can find it and get you back on track. All right, but a good problem set there to put everything together. 7 properties, everybody, and a variety of examples to kind of solidify that piece. Hey, of course, thank you for listening, and try the practice problems. Get some practice on this, and check in with me and check in with others as well. Thanks.